Hello, welcome. This video is the continuation of Cloud Native Ninja series. So far in this series, we have seen how to build a .NET application or an application using the Dapper distributed application runtime, and we started with .NET Core as an application programming language. So far we built two services, the TechTalks Producer and TechTalks Consumer, and then we used Dapper as that distributed application runtime to communicate with our external dependency, which was the RabbitMQ message broker. And until now, we have seen how to use multi-stage Docker build in order to optimize the image sizes for our custom application specific Docker images or container images. In the last session or last video, we looked at how to use the Alpine based Docker image for the .NET SDK and also for running ASP.NET runtime version of the image. We also saw how to build and how to run the containers. So in the first part of the series, or the second part where we started with how to use containers for application development, we looked at how to run RabbitMQ containers on our local development environment without having to install any RabbitMQ related software. Then in the past video, we looked at how to build our custom Docker image or container image using Docker build command using a multi-stage build, and we also saw how to run that image. So we built our producer and consumer images, and we also ran those images locally on our machine. Now in our application, it is quite simple. We just have one external dependency on RabbitMQ and we are building two microservices. But in real life, you might be working with an application which has a lot more than just one dependency. We might be using things like databases, we might be using caching services and various other external or third-party services. In terms of the actual microservices developed by the application itself, it could be much more than two of them. Now, the problem we saw last time was we had to start each of these dependent services like RabbitMQ by running the Docker run command. And same thing when we were building and running the application. We had to individually go and run this lengthy Docker run commands. It would be easier if we can just run, let's say, one command and spin up the entire development environment that is required for building and testing our application, which is built using microservices. That is where today's discussion is heading towards, and we are going to see what is called as a Docker Compose. So let's head over to the browser, or let's head over to the terminal and see what do we need for Docker Compose. Docker Compose is actually a project which started initially in 2014 in order to allow developers to have a local development experience and to enhance their user experience in terms of building and testing or running multi-container applications. Docker Compose initially started in Python, and over a period of time it was rewritten in Go. And now if we run the Docker Compose the old way, the earlier version was docker-compose, and if we run the version command on that on the terminal, we see it is version 2.13.0. and since it's rewrite in Go and its integration with desktop tool like Docker Desktop, it is part of the Docker main commands itself. So we have a similar version which can be called using Docker Compose and version, and that also is currently v 2.13.0. It is also packaged as part of Docker Desktop. So if you are using Docker Desktop, we can see the Compose version 2.13.0 is packaged along with Docker Desktop itself. So if you have installed Docker Desktop, there is nothing separate that we need to install. If not, if you're not using Docker Desktop, then we will have to install Docker Compose separately. So let's go and see what is that we can do with Docker Compose. Like Docker, we use a conventional method. When we are starting with building the Docker images, we start with a Dockerfile. So when we are working with Docker Compose, we also have a file called Docker Compose. And let's look at the bare minimal or very simple Docker Compose file. How does it look like? I'm going to use this for the RabbitMQ container that we were using RabbitMQ image. So we start with a version which talks about which version of Docker Compose we are using. There are different file formats or different versions supported by Docker Compose. So I'm using 3.4 for the RabbitMQ specification here, and the details or the attributes related to Docker Compose, we specify them in YAML format, and the extension of the file is .yml. Unlike Dockerfile, which doesn't have any extension, Docker Compose does require a .yml extension. So once we have specified which version of Docker Compose we are using, we start with a list of services. So these are all the images or the containers that we want to run as part of our application. In this case, I have a service named RabbitMQ, and the image is the RabbitMQ with tag 3 management Alpine. I'm going to switch over to the Alpine version of the image, and if you have seen my earlier video, it is quite lightweight. It gives us one of the shortest size or one of the smallest size in terms of images. That is why I'm using the Alpine version. And then whatever we wrote as part of our ports mapping on the command line, we do that as part of the ports attribute here, or ports field, and we map each of the port that we want to map on the host to the port that is exposed by the RabbitMQ container. So we are mapping 15672, 5671 and 5672, these 3 ports on our host machine to the container ports. And then we also specify if there are any environment variables. So in the earlier video, I had shown how to override the default username and password for RabbitMQ. I'm doing the same here. This is for the demo purpose. There are better ways of not putting clear text username and password, but for the simplicity of this demo, I'm putting it in clear text. Please do not do this in your actual development. So once we have this, we can head over to the terminal and start using this compose file. So let's do a list of the folder, or where I'm currently in the projects folder of Cloud Native Ninja project, and here we have this same Docker file or Docker Compose file which we were looking just now. Let's start by running the first command, which is, I will use the legacy method first, which is the Docker Compose or Docker-compose, and we can just start with let's say up. Up is one of the command which is used to start all the services within the Docker Compose. So here we can see that it is pulling the RabbitMQ image and all the different layers associated with that. While it is being pulled, let's also list down all the Docker images that we have. So right now I have only 3 images, the Redis, Zipkin and Dapper. This is what is used by my Dapper component, and those are the only 3 images which are available locally on my machine. That is why when I do Docker Compose up, it will also pull the image if it is not available locally. This is exactly same way as it happens when we run the docker run command, and if the image is not available, it will pull the right version of the image for us. And once the image is pulled, we can see that it creates a network called as Cloud Native Ninja default, and it creates a container, and then it attaches the terminal to that particular container. Now let's go back and run the docker images command once again and see, did we get the image downloaded. So we have this 3 management Alpine tagged image of RabbitMQ, and that is downloaded. We can also see which are the containers which are running. So if we run the docker container ls command, we would be able to see all the running containers, and here the first image that is shown, the RabbitMQ image, is the one which is started about 40 seconds ago, and we can also see the port mapping done for that, for those ports which we are exposing. So we now know that using the Docker Compose up, we are able to run the container image, and as the image starts running, we can also see the logs coming from that. And in this case, our terminal is attached. We can also run it in the detached mode. So let me go and slightly change this. I'm going to go to the same folder once again where that Docker Compose file resides. If I want to stop the running containers, I can stop this terminal here itself. I can use the Control C to stop the running containers. The other way, and a better way of doing that, is we can use the Docker Compose itself to make sure there is a graceful shutdown of all our containers running. So like we did with the up, there is a Docker Compose down command which we can use to stop what is currently running and what is currently started as part of the Docker Compose up. So we can see that it is stopping that RabbitMQ container, and it will also clear the network which was created. So both of them are removed, and if we go back to the previous tab, we can see here that RabbitMQ has exited. So once it has exited, it will come out of that terminal. The other things we can do is, so that was quite simple, right? We had a RabbitMQ image, or we had to start RabbitMQ. We provided all those things that are required for running that image in a declarative way in a YAML file, specifying the service, the name, and the different attributes. Now let's look at how we can use this for our own application, because this RabbitMQ image we are using from the one which is provided by RabbitMQ as an official image on Docker Hub. So for my application, I want to build the TechTalks producer and TechTalks consumer. These are the two images that I have as part of my application. So I do a similar thing, like I create a file called as Docker Compose Docker Hub with the intention that I will be pushing these images to Docker Hub later in the series. I start with a version. Again, I specify version 3 for the Docker Compose. In the list of services, I provide TechTalks.producer as one of the service. And the difference here is, along with the image, we also specify the build context or build related attributes, because we are also building this image, or we want to build this image. As part of the context, we specify where the Docker file resides and then the name of the Docker file. So if you remember from the earlier video, we had used this Dockerfile v3 with the Alpine based images, and that is the same Dockerfile, multi-stage Dockerfile I'm going to refer here. When it comes to the consumer, it is again similar. We are going to use the image Nilesh Kule TechTalks consumer and tag it as .NET, and we are going to build that image using the Docker file named as TechTalks consumer. And this is under the src.net folder. So once I have this Docker file, how do we use that Docker file to use with the Docker Compose? Now I'm going to switch from the old version of docker-compose to the new command, which is almost similar to the old one, but it is part of the Docker main commands. The syntax is almost similar. And if you want to know what are the different features or different commands available, good thing with all these CLIs is we can use the help command, and we can run whatever command we want to run, and then use the help. So for the Docker Compose, it supports all these options like -f or -f for providing the file. We can provide things like a different profile, project name, and then the commands like we can use the build command, we can use convert, down, up, exec, images, skill, and all this kind of other sub commands which are part of Docker Compose. So let's use this version, which is part of the Docker main command itself, to build our image or images in this case. So let's start with the Docker Hub YAML file, which I was showing just now, and I'm going to use the build command to build the images, because we have the build context specified, or I want to first I want to first build the images before I make use of them, because I don't have them built locally. So here, let's trigger the build here and see what happens. So it is starting to build both the TechTalks producer and the TechTalks consumer, and we will see that it will follow those instructions which were specified in the Docker file for both these different microservices, and it will build the images. So once the image is created, we can then go back and look at the Docker images and the Docker Compose commands, the remaining commands. It will take few seconds for the image to be built, and currently it's building the consumer one. The The producer one is already built. Let's give it few seconds. So what this has allowed us to do is to combine all the microservices within our application and the steps for building those application specific microservices in one single place. And we can use one file instead of running the build command separately for each of the microservice. I can build all of them together using Docker Compose Docker Compose build. And shortly we will see how to use the Docker Compose up command to start all those services. So both the TechTalks consumer and TechTalks producer have been created, the images. We can verify this by using different methods. First, let's use Docker and see using our normal traditional way Docker images. If we do here, we should see the TechTalks producer and TechTalks consumer created 2 minutes and 26 seconds ago. Then let's look at using the Docker Compose itself. So initially or earlier we ran the build command using this file, the YAML file. We can also run the images command here, Docker Compose, and if we give the file name and the images, it will tell us what are the images built using this particular Docker Compose file. Looks like there is some problem. Okay, never mind. Let's do one thing. Let's use the up command and see how we can bring these images up together. So earlier we were using the docker run command. Now if I use the up command here, Docker Compose, give the file name, and up we can see it creates a network, then it creates a producer and it creates a consumer, and it will attach our terminal to the logs of those two, producer and the consumer. We can also verify this by going back and say Docker Compose. We use the same file, and in here let's say PS. So we can see the producer and the consumer processes running, which were part of this docker hub.yaml file. We can also go back on the Docker and say Docker container ls. Here we will see all the containers, not just the ones which were created as part of the Docker Compose, but also the ones which were earlier started by the Dapper or whichever other containers were in the running state. So this way we can start all the services which are part of the Docker Compose file. Now let's bring this down and try one more thing, which is to say, let's say in this case I have two services and I'm building, I'm running, I'm bringing them all down together all at once. But if I want to do only one change at a time and without impacting the other services, if I want to see that change, how can we do that? So I'm going to use one of the file, let's say the consumer that we have, where we are writing the log file. So in our consumer minimal file, we have this logging which is happening, and let's say I change the text here of the log. Instead of saying category, I say TechTalks category or TechTalk category to be consistent with the earlier log. And for the level as well, we go and change this to say we are going to change the log content to write this TechTalk along with the category and the level name. Now I want to build only the consumer in this case. My producer has not changed. So what I can do is in the Docker Compose, I can specify which particular service has to be built. So we use the same file, and along with the build command, we give the name of the service that has to be built. So if I give techtalks.consumer in this case, it will build only the consumer service without rebuilding the producer. So let's see what happens when we give the specific service name. So in the log, we see only the build context for the Dockerfile TikTok's consumer is being used, or the build definition from that file is being used. It is not going to pull, or it is not going to build the TikTok's producer, because we have used a specific service here. This should be done in a few seconds. Once this is done, the other thing I would like to show is with the docker run command. If we go back to the earlier session or earlier video, we saw that we can run the docker run in two different ways. One which is in the interactive terminal, and the other one is in detached mode. Same way with the docker compose also, we can run docker compose in the detached mode as well. So while this is building, let me switch over to the other tab and we can see that functionality. So let's clear the screen and let's say docker compose, and I want to use this file. The Docker Hub, Docker Compose Docker Hub. Let's do up here, and we do it in the detached mode. So the detached mode setting or the flag is -d. When I give -d, what we will see is it will run similar to the earlier run when we were running the Docker Compose in the attached mode. It will create the network, it will create the producer and consumer, but it will not attach the terminal to the standard output of those containers. And if we go back again, and here we do the ps command to know what are the processes which are running on the Docker Compose, we see that the producer and the consumer has been started, which means it is running, but our terminal is not attached to that. And if we go back to the other terminal, we can see that now in here only the TikTok's consumer has been built. So this was that specific service which we were trying to build. So this way, instead of building all the services, if there is change only in one specific service, we can use Docker Compose to build only that one single instance of the service. The other feature which I would like to show is, in this case, what we are seeing so far is we are using only the producer and consumer to start, but our application also depends on the RabbitMQ to start it. So we can use multiple files and we can start all the services defined in those multiple files. So let's look at that scenario where let me go and copy the command instead of typing it all together, just to avoid some typos and save some time. So we use the same Docker Compose command here, but we specify multiple files. And the Docker Compose file is the one, the default Docker Compose, which contains the RabbitMQ related settings, and the Docker Compose Docker Hub YAML contains the producer and consumer related settings. And then we want to do up here. So if I run this now, what would happen is it will combine all the services from these two Docker Compose files, and it will run all of them together. We can see that RabbitMQ is getting pulled again because during the building of this earlier images, I just cleared all the images, and that's why the RabbitMQ image got deleted from my machine. That is why it is pulling it again. But if we had the RabbitMQ image already, it would not pull it again from the Docker Hub. It would start that image immediately. So once we have all this image pulled, what we should see is it creates again the RabbitMQ producer and consumer along with the RabbitMQ image. So all three are running now, and we can again verify this by running the docker container ls command. So we have all the three things running here: the RabbitMQ management image, Alpine image, the producer and consumer. And we can also use the same old command like we did with the Docker Compose. So instead of using the Docker images command or Docker container ls command, we can see here, if we do the ps instead of up, if I give both the file names and I use docker compose ps, it will show me the processes or the running containers which are part of only these docker compose files. So with that, what we saw is it is quite easy to build this multi-container images, to run these multi-container images using Docker Compose, and also to compose different parts of the application. Here in this example, we saw that our application specific images are in different Docker Compose file, and the dependency, which is RabbitMQ, is in a different Compose file. But when we want to run all of them together, we can specify multiple Compose files, and Docker Compose will spin up the container instances for all those dependencies and our applications together. So let me quickly go back and see if there was any command which I wanted to show but I missed during this demo. So we looked at the Docker Compose legacy. I just showed the version and the Docker Compose up command using the legacy Docker Compose version. It is better to use the one which is coming with the packaged with Docker Desktop, which is the new version. It is built using Go and it's much more performant compared to the old Python version. So we use Docker Compose, which has a similar capabilities and same set of subcommands. So we use Docker Compose up to up the containers. We looked at what are the processes which are running using Docker Compose PS. We also used a custom compose file rather than just using the conventional Docker Compose as the name, and we also saw how to use it in detached mode. And once the specification, or once we are done with the testing or building the application and running it, we can bring all those services down with Docker Compose down. We saw it in both the cases using the default as well as a custom Docker Compose file, and then how to build all the container images in a particular compose file as well as a specific image. So with that, I think we have covered most of the things that I wanted to show in this Docker Compose features. So that is what we saw as part of building or running the RabbitMQ image using Docker Compose. Then we looked at the TechTalks producer and consumer, how we can specify the build context and provide our own application specific metadata like the Dockerfile and the context for building the image with a specific tag. We also looked at some of the commands like build, up, down. I didn't show start and stop, but these are similar to up and down, where it will start the services and it will stop the services. PS, we looked at it, and here on the right hand side I've given the screenshot of that help command, which shows all the other commands which are available along with Docker Compose, like the logs. There is a list of running compose commands. We also have the push or pull mechanism to pull and push the images to the container registry, and we will look at these in the later parts of the series. So what we looked at is Docker Compose helps us to set up the local dev environment very quickly using these compose mechanism, where different compose files can be brought in together to spin up all the containers required for running the application. It is quite helpful in doing end-to-end test. When we want to test the application locally, we can build all the dependencies, not just our own application, but whatever it might be depending on other microservices. We can create those instances and run end-to-end test locally. And we also saw how to combine the compose files. This feature I particularly like because we can then create different variations of the compose file. Let's say one for the dev environment, one for integration, one for other kind of let's say performance testing or automated UI testing, and based on the kind of test that we want to run, we can spin up a different version of our containers. So that's quite a handy feature, I find. If you would like to know more about Docker Compose, I've given some links here about the quick overview of Compose, how Docker Compose evolved from the Python to current version built using Go. Also the versioning. So currently there is the Compose version 3, which is the latest, or 3.9 to be very specific. From June 2023, the version 1 is going to be deprecated. So if somebody is still using version 1 of Docker Compose, you need to migrate quickly to the version 2 or version 3. Like we did for the Docker, I've also provided links to the cheat sheets which are available for Docker Compose. And if you would like to have a look at the code that I'm using for this complete series, it is available on GitHub. The name of the repository is Cloud Native Ninja, and the slides used during this session as well as the previous ones, they are published on SlideShare and SpeakerTech. I hope you find this useful. In case you would like to contribute to the Cloud Native Ninja series, I'm open for the pull request and contributions. Please have a look at the sections which are marked as needs help, and if you are an expert in those areas, feel free to contribute. Thanks for watching this video. Until next time, code with passion and strive for excellence.